Hey everybody, now we're going on to chapter 4.5, and this section is all about solving equations. So, solving exponential equations, and then at the end solving logarithmic equations. And we're going to start easy, and we're going to work our way to harder problems. Alright, so, trying to figure out, there we go. Okay, so the first rule is pretty happy. It says, if you have the same base, notice that the bases are the same, and there's one base on each side. So you have then, so you have, let's see, a to the equals a to the and that's it. Nothing else. There's going to be nothing else on this side, and there's nothing else on this side. If I put a 3 in front of it, it doesn't work. If I put a 5 in front of it, it doesn't work. If I put plus 7 to it, it doesn't work. It's just a very basic equals and if that's the case, the two exponents must equal each other. So it says if you have this very specific type of equation, then the exponents must equal. That's it. That's all the rules saying. So keep in mind that this is very specific, but we're going to start there and work our way to more broader stuff. Very specific. So anyway, let's look at our first problem. So we're going to work our way through them. So A, notice that we have the same base. 3.873 is my base. 3.873 is the base. Now, in this equation, we have our two exponents. According to the theorem, x must equal a. And that's it. Isn't that the happiest problem ever? Okay. On the exam, they're not going to be that easy, but I just wanted to show you what we're talking about. Let's go to the next one. 3 to the x plus 1 equals 81. So here, this is more in line with what you're going to see on the homework. Okay. Notice that they're not the same base. So we can't use the exponents yet. So instead what we need to do is I need to turn 81 into a power of 3. And it turns out 81 is 3 raised to the 4th power. Right? So now they're the same base. And since they're the same base, I can get these exponents and I can set them equal to each other. X plus 1 is equal to 4. Therefore, x equals 3. So as far as powers go, there's some powers that you kind of have to get used to seeing because, well, you'll see them a lot. For powers of 2, there's 2, 4, 8, 16, 32, 64, and so on. And these are just 2 to the 0, 2, or sorry, not 2 to the 0, 2 to the 1, 2 squared, 2 cubed, 2 to the 4th, 2 to the 5th, 2 to the 6th. And for powers of 3, we don't expect you to know as much. 3, 9, 27, 81 is pretty much it that I'll throw on an exam. On your homework, they're randomly generated, so some people might not get lucky and get an ugly number. But you can always use your calculator to figure out what power it is. 3 to the 1, 3 squared, 3 cubed, 3 to the 4. for 4, 16, I think it's 64. And that's all I expect you to know. So that's 4 to the 1, 4 squared, 4 cubed. For some reason, I'm doubting myself on that one. Let me double check. 4 is 24. 24. 6. Yeah, 64. Okay. And then for 5, no, the 5, 25, 125 is really all you need to know. 5 to the 1, 5 squared, 5 cubed. Okay, so these are the numbers you'll see when they want you to do a mental conversion. Notice I didn't use a calculator. I already knew that 81 is 3 to the 4th. Let me shrink that, move it over here. Anyway, let's go to the next problem. So here, if I look at these, I have the 4 and the 8. We notice that they're not the same base. Okay, but they share something in common. Remember when I wrote the 2's? For the powers of 2, it was 2, 4, 8, 16, 32, and so on. And this was 2 to the 1st, 2 squared, 2 cubed, 2 to the 4th, 2 to the 5th. And my numbers, 4 and 8, happen to be right here. These are both powers of 2. And because of that, I can rewrite the problem in terms of powers of 2 and solve it. So 8 can't be written as a power of 4, well, cleanly. And so I rework it. So 4, I'm going to put parentheses. All right. So the 4 becomes 2 squared. And the 8 becomes 2 cubed. And there's a rule that says if you have a to the m raised to the n, it's just a to the m times n. You multiply the exponents. So this becomes 2 to the 2 times 2x minus 1. You can distribute it mentally if you want. And this is 2 to the 3x plus 3. I notice now we have the same base. I'm going to go ahead and distribute. So 2 to the 4x minus 2, 2 to the 3x plus 9. So now they're the same base. And so I can set the exponents equal. So the only trick to these that makes these harder is you have to do some work to get the base to be the same. But now that it is the same, this is just 4x minus 2 equals 3x plus 9. And we can just solve by moving stuff around. So minus 3x minus 3x. X minus 2 equals 9. Add 2. X is equal to 11. 3x minus 9, yeah. All right. Isn't that fun? So that's a medium level problem. Working our way to something a little harder. Now, knowing my powers, I know that the powers of 9 are 9 and then 81. Where 9 is 9 to the first, 81 is 9 squared. So my common base here is going to be 9. I have to turn the 81 into 9 squared. But before I do that, I got to kind of work with it a little. So I have, well, no, we can work with it now. So, hold on. what's the cleanest way without confusion that I can do this? Let me pause this. I need to think of the best way to explain it. Alrighty. So, sorry about that. Here we have 9 to the x plus 1 is equal to 1 over, and remember 81 we can write as 9 squared, but then it's raised to the x, so let me put parentheses. But the rule over here says that if you have an exponent raised to an exponent, well, if you have a term with an exponent in it, and then that term is raised to an exponent, you multiply the exponents. So this is just 9 to the x plus 1 equals 1 over 9 to the 2x. Now you may be thinking that this is the same base, because you see a 9 and 9, but remember the format. The format has to be, a to the equals a to the and then you set those equal. What I have here isn't that. What I have is a to the equals 1 over a to the and it's not a match. So I can't use the rule yet, but what I can do is go over some exponent laws from many moons ago. We know that a to the n is equal to 1 over a to the negative n. Okay, so what this means, or we can do it reverse, a to the negative n is equal to 1 over a to the n. I'll use that one first since the negative sign. It's the same formula, but I don't want to be confusing. All right. So what we do is whenever you have an exponent in the denominator, it's really a negative exponent. Okay. So what we're going to do is we're going to move to the numerator. But the cost of doing that is you have to make the exponent negative. Let me erase this stuff over here. All right. So I have 9 to the x plus 1 equals 9 to the negative 2x. And so now it's 9 to the equals 9 to the and I can set my two expressions equal to each other. X plus 1 equals negative 2x. And to solve that, I just add 2x to the other side, and then subtract 1, and divide by 3. There you go. All right. Keep chugging. 2 more. So this is pretty much the same idea that we just did, except now it's with 7s instead of 9s. So let's kind of do what we did. I know that we have 7 and 49, where this is 7 to the 1, 7 squared. So my equation is going to be 7x plus 1 equals 1 over, parentheses, 7 squared. And then I have the 2 minus x. I multiply the exponents together. So 7 to the 4 minus 2x. And then I could do the rule where I move it to the numerator but make exponents negative. So I'm going to move up here to do that. So I have 7 to the x plus 1 is equal to 7 to the, and notice what I'm doing. I'm making it negative, but the negative affects the whole thing. So negative 4 minus 2x. Then you can distribute that. Negative 4 plus 2x. So now the bases are the same. So now I can set the exponents equal to each other. So I have x plus 1 is equal to negative 4 plus 2x. And we just solve it. This is a happy equation. Subtract the x to the other side. Add the 4. And there you go. X equals 5. Yay. So this last one is a little trickier. Notice that you see the same exponent, but we can't use the rule because of this 16. Remember, it has to be, when we went way up here, it has to be very specific. There can't be any numbers in front of either term. There can't be any numbers being divided. It has to be very, very, very basic. So that 16 is messing things up. But since I know my powers, I know it's 4 and 16, where this is 4 to the 1, 16 is 4 squared. So let's see if we can do something there. I have 4 to the 3x over 4 squared, 4 to the x squared. Now with that 16, another rule is if I have a to the n, divided by a to the m, this is just a to the n minus m. So we're subtracting. So that means that I can turn this into one exponent. This is 4 to the 3x minus 2. This is 4 to the x squared. Now I can set the exponents equal to each other. Now this one's different from the other 6, or the other 5, in that it is a quadratic. So I have 3x minus 2 equals x squared. And we have a quadratic, which means that the only ways to solve a quadratic are to factor or use the quadratic formula. Okay? You can't solve by moving things to each side. Now, all the equations that we did before, x plus 1 equals negative 2x, x plus 1 equals 4. Where's the other one? 4x minus 2 equals 3x plus 9. Those were not quadratics. The power of x was raised to the 1, and the way to solve those is you just move things around to each side until you get the x by itself. You can't do that with quadratics. It's a completely different type of problem. So instead what we do is we factor or use the quadratic formula. So I'm going to get everything to one side. Basically, I'm going to subtract 3x and add 2. And notice there's my quadratic, x squared minus 3x plus 2. Notice this one can be factored. This is x minus 2, x minus 1. So x equals 2 and x equals 1. We have two solutions. Okay, so notice that we started with an exponential. Okay, it was divided by 16, so we used the division rule for exponents, where you subtract the exponents. And then, once they're the same base, you set them equal to each other. But unlike before, where it was linear, this one's a quadratic, so you got to get 0 on one side and factor. All right, so those are the easy problems. Let's spice things up a bit. We're going to add some logs to equations. Did I put that in the right spot? Let me see. Yeah, no, they were good. Okay, So what we're going to do, there's the cat. Like, why would you do that? We're going to get equations, and we're going to add logs to them. ¿Por qué? All right. Why would we make a problem more complicated? If you look at this, it says if you have a happy equation, just chilling, doing its own thing, if you put a log on both sides. So wrapping each side in a log is legal. But it has to be the entire side. You can't pick and choose what you log. Okay, so why would we do that? Why would we get a problem, and why would we make it more complicated? Notice we had m and n. It's the same thing as log of m equals log of n. So I wrapped a log on each side. Okay, you can't cheat. Must be, again, the entire side. Kite. All right, so here's the idea. There's two ways to do these. I'm going to do it both ways and show you how they're pretty much the same thing. But you're going to get equations where the bases can't be made the same. For instance, 3x equals 5. Your base is 3, your base is 5. Oh, got an email. Okay. The base is 3, the base is 5, but 5 is not a power of 3. In all the problems before, it was like 7 and 49, 9 and 81, and so there were obvious powers. Here, this is not an obvious power of 3. So the question is, 3 to the x equals 3 to the what? I don't know what is going to give me 5. And that's where the logs come in. Now, one way to do it is what we say log both sides. This is a very powerful move. If you log both sides, this allows you to use log rules. Allows you, no, not log rules, but allows you to expand, condense, etc. Okay? Usually the rule that you're going to use, though, is the power rule. Remember, the power rule says that log of m to the r comes to the front. So the r comes to the front. And then you solve for x. The other way to do it is just to convert and solve. So I'm going to show you, let's do both ways. We'll start with 2x equals 7. This is the happiest problem. Now, if it was an 8, I could do it like I did on the previous page. But this is a 7. So I don't know 2 to the what equals 7. I have no idea. So let's work it out. We're going to start by logging both sides. I have 2 to the x equals 7. So that's a legal move. Now, because of the power rule, I know that x can come to the front. So x log of 2 equals log of 7. And then I divide both sides by log of 2. Let me shrink it so I can fit everything. So now I have x is equal to log base 7 over log base 2. All right. Now the other way to solve it, this is solving with logs. We can also solve it by converting. Okay, so if we want to solve by converting, okay, 2 to the x equals 7. I want to convert this into a log. So I know my base is 2. So I know that this is going to be log base 2. And then my exponent becomes the answer. My answer goes on the inside. Remember, they swap places. This is what we did way back in, not way back, last week when we were doing section 4.2. Okay, so my exponent becomes the answer. The inside becomes the answer, which was the x. And the answer goes on the inside. And notice there's my answer. X equals log base 2 of 7. Okay, so are these two things the same? Let me rewrite it so it's just more. So log base 7 over log 2, log 2 over log 7. Now these two equations are the same because of the change of base rule. Remember that we can always change the base to be log of 7. The old base is 2, so I divide by log of the old base. So whichever way you decide to do it will work. Over time, the homework's going to start preferring to log both sides. But I will not count it wrong if you convert, because a lot of these can just be converted and solved. All right, so that's the first one. Let's go to some that are a little more complicated. Okay, so the second part tells us that there's a certain time in the equation when we log. So only log both sides. When the exponential term, where I'm going to put it in a different color, where a to the n is by itself. Okay, it needs to look like a box and not 0. Okay, so only log both sides whenever the exponential term is by itself. Here's the exponential term. Notice that it is not by itself. So I want to hold off logging until it is. So what I need to do is I need to divide by 8. And so now I have 3 to the x equals 5 over 8. And you can solve it however you want. You can log both sides, or you can convert. So if I choose to convert, the base is 3. Log base 3, the answer goes on the inside, and the exponent becomes the answer. And so notice you get your answer right away. X is log base 3 of 5/8. Now, because we're doing it both ways, let's log both sides. You got options. So the other way to do it is to log both sides. So log, and you have 3 to the x equals 5/8. That can go to the front. X times log 3 equals log of 5/8. And then you just divide by log. Yeah. So x equals log of 5/8. And you can leave it like that. You don't have to be a hero. Just, if they say round to the nearest decimal place, then they want you to type this in the calculator. Notice both of these are the exact same solution. If you change if you use the change of base formula, you get the same thing. Or basically, if you wanted to type this in your calculator, you would do log of 5/8 but then we have to divide by log of the old base, which is just this. Right. Let's find the exponential term. So in this one, here's the exponential term. We can only do our stuff once it's by itself. So all they want you to do here is to subtract the 820. Now let me go to my calculator. And let's figure this out. So 4,9,600 minus 820. 48,780. So I have 10 to the 5 plus 2x is equal to 48,780. And we want to solve it. Now this is one where I'd want to log both sides right off the bat. Notice the base is 10. If we just log both sides, the log and the 10 will cancel out. So that's a good thing. So in this example, I'm going to log both sides. You could also convert. So 10 to the 5 plus 2x equals 4,8,780. Okay, so you can think of this as the log and the 10 canceling out, or if you want, you can have the exponent come to the front. But remember, it's the entire thing. It has to come together. Okay, so the exponent, if it's more than one thing, it comes, when you bring it to the front, it has to come to the front as a group. You have to put it in parentheses. I have no idea what that number is. Okay, but log of 10 is just 1. You can even type it in on your calculator. Log of 10. So I have 5 plus 2x is equal to log of that ginormous number. And we can just solve for x. So I subtract 5. Let me use a different color. Minus 5. Minus 5. Now the 5 can't mix in with the log. That's illegal. We have 2x equals log of 48,780 minus 5. And then the last step is to divide by 2. Divide everything by 2. Okay, you can't pick and choose what you want to divide by. You divided the left side by 2, so you have to divide the right side by 2. There you go. 48,780 minus 5, the whole thing over 2. And that is your answer. Walk away. Good stuff? Again, if you had converted, it would be log base 10, which you don't have to write it. The inside becomes the answer. The answer goes on the inside. And notice we get the exact same thing. This step is identical to what we had here. And so if you solve for it, you're going to get the same answer. Yay? Yay. Okay, last one. Before we go to the ugly one. Dun, dun, dun. Dun, dun, dun. All right. So here's a traditional exponential equation with e. So my base term is right there. It's not by itself. So I have to divide by 18,000 to get it by itself. Again, you can use your calculator. It's pretty happy though. So 1/9 equals e to the negative 0.4t. And again, we want to solve. So if you're converting e, it would be log base e. And the inside and the outside switch places. The answer is 1/9, so the answer goes on the inside. The inside is negative 0.4t, so negative 0.4t. And notice from there, you can just divide by negative 0.4. So log base e is natural log. You don't have to write the e, but so whenever you see ln, that is log base e. It's bad manners to have a negative in the denominator, so I'm going to put the negative on the top. And there you go. There is your answer. So when you're solving these, converting is actually it's very streamlined. The book wants to introduce that logging both sides is legal, so they tend to log both sides when they solve, but you can always convert. So again, I'm going to do this one more time, but by logging both sides. So log of Since my base is e, I'm going to do ln of It doesn't matter what kind of log you do. And so 1/9 e to the negative 0.4t. What happens is this comes to the front, or you can think of the ln and the e canceling out. And you end up with ln of 1/9 equals negative 0.4t times ln of e. But ln of e, just like before, is 1. Second, divide to bring the e. Ln of e is 1. So this guy is 1. And notice we get the same answer. I'm going to put the negative on top because it's bad manners to have it on the bottom. And notice you get the same thing. Yay! So however you want to do it, perfectly fine. On the exam, if you choose one way over the other, neither will, you won't lose points. Okay, the only thing that you will lose points is if you just put the answer and say, my calculator did it. Then yeah, that won't get any points. You have to have all your work shown. All right. Now, so the beginning problems were the easy ones, same base. These are a little harder. And now we get to the ugly ones, the nasty ones. And so I put the bunny because if you look at the problem, it looks adorable. Like, oh, that looks so cute. It's just so, man. But when you actually try to solve it, it's going to end up being a lot of math. So that's why I put the bunny eating the skull. Okay, so I could read you all these rules, but I'm just going to work this problem out. And then I want you all to work out the second one, and I want to see how y'all do. So you're going to be doing number 2 on your own, and I'll post the video to Canvas. Okay, so looking at this, if this was a 4, then I would just make this the same base. And then you would have your exponent equals your exponent, and it's no biggie. But it's a 5. And so because it's a 5, I can't do that. So this is where converting becomes an issue because there's 2 bases. Convert to which base? So in these, logging both sides is the main approach. Again, it doesn't matter which one you choose. You can use log or natural log. So here I'm just going to choose natural log because I'm trying to be different. Some people like writing natural log because it's one less letter to write. But you put the left side equals the right side. And then you have these exponents. And they're going to come to the front of their own log. Now when they come to the front, they come to the front with parentheses. Now this looks very foreign to people when they see this, and they kind of freak out. But if you were dealing with this, this is a completely different problem, just totally off the wall. What would you do? 5 parentheses x plus 3? Well, you would just distribute. And you would get 5x plus 15. Well, that's exactly the same thing that we're doing here. I have a number times x plus 1. I have a number times 1 minus 2x. So if you want to make it a little visually appealing, you can put the number on the left if you want. Doesn't matter. Okay, so these are still two things being multiplied. But this ln of 2 and this ln of 5, I'm just going to distribute. They're just numbers. In the previous problem, or in this completely random problem that I made up on the fly, this 5 distributes to the x plus 3. So 5x plus 15. So same thing here. The ln of 2 distributes to the x plus 1. So what you get is ln of 2. Now they don't mix, so it's just ln of 2 times x. ln of 2 times 1 is ln of 2. ln of 5. Again, the 2x and the ln of 5 don't mix. So it's just ln of 5 times 2x. There we go. And so once you're at this step, your goal is to get all the x's on one side and factor it out. Everything else on the other side. Okay, so that's going to be our goal. Now, usually what I do, let me duplicate. Let's see. There we go. I'm going to drag this over here. Okay. So what we do here is I want to get all my x's on one side. So this guy, I want to move over there. Whereas this one doesn't have an x, so I'm going to move it over here. That's being subtracted, so I have to do that with addition. This is being added, so I have to move it to the other side with subtraction. So if we move things around, we get ln of 2 times x. I add it to the other side, so it's going to be plus ln of 5 times 2x equals ln of 5. And then I subtracted the ln of 2. There you go. You got all your x's on one side. Now, both of these have an x in common, so I can take the x out. There you go. And then the last step is to divide by all that ugliness right there. and that's going to be your answer. So x is equal to ln of 5 minus ln of 2 over ln of 2 plus 2 ln of 5. Now, if you type that in your calculator, you have to be sure to type it in correctly. Your numerator has to be in parentheses. Close it. Close it. Close it. Divide it by, open it. Close it. Plus 2 ln of 5. Close it. Close it. And so this is about 0.2342. But the answer that I'm looking for is this guy. So notice that it looks nasty. But that's the answer, and this is the way to do it. The thing is, though, the solving process is exactly the same no matter what you do. So no matter how the problem changes or what the exponents are, the solving process is going to be exactly the same. The only time there's a shortcut is if the bases happen to be the same. So if I have 2 to the x plus 1 equals 8 to the 1 minus 2x, then I can skip this entire process. I can skip it because I can write 8 as 2 cubed. And then you can just set the exponents equal. And notice you just skipped all that ugly bleh. So if you see an easy way out in that the bases are the same, or can be turned to be the same, then do that. But if the bases can't, 2 and 5, they can't do that. 7 and 4, you can't do that. So you have to do it the long way. Anyway, go ahead and work on this problem. I'll post the video to Canvas so you can see if you got it right or not. But I can guarantee you that this problem will be on the test. Okay, so you're going to see that question as one of the questions to solve, and you have to know how to solve it. Okay, there's no escaping it. All right, so work on that one. But let's go on to solving some logs. So we're almost done. We're going to solve some logs, do some word problems, and that's it. So just like I can add logs to equations, it turns out if you have one log on each side, again, very basic. So if you have only one log of the same base, so I'm basically just repeating what this is right here. This is the only log, only thing on the left. This is the only thing on the right. Okay? If you were to put a 2 in front of it, it wouldn't work. If you were to divide it by 7, it wouldn't work. Okay? It's a very specific kind of setup where all you have is one log equals one log. If that's true, then you can take the logs out of the equation. You can cancel them out. And all you're left with is the inside equals the inside. So that's the goal here. So let's work on these. Now, whenever you get the equation, they're not going to be set up like that, where it's one log equals one log. What you have to do is, that's what steps 1 and 2 here are. You have to use your log rules to force one log on each side. So you're going to have to expand and condense. Well, in this case, not expand, but you're going to condense. Okay, and the goal is to get one log on each side. So let's look at this first problem. 2 log base 5 of x equals log base 5 of 9. So looking at this, notice that it is not in the right form. Here's my log. Here's my log. But there's the 2 here that's messing me up. So what I need to do is condense. So that means that I need to get this 2 and make it an exponent like we did in the last section. So I have log base 5 of x squared equals log base 5 of 9. And now it's 1 log equals 1 log, so I can cross the logs out. They kill each other. And I'm left with x squared equals 9. It's actually bad manners to say the logs cancel out. So I'm just going to just write the next step out. Basically, you can drop them. So I have x squared equals 9. I take the square root of both sides. So x is equal to plus or minus 3. Don't forget the plus or minus. All right? So there you go. You get plus or minus 3. But I want to show you this graph on Desmos. So if I go to Desmos, let me get my keyboard. Desmos. Desmos. Okay. So I have 2 log base x equals log, oh. So there's 2 log base x, and here's log base 9. I'm going to put y equals. Okay. So if you look at the graph, how many times does it cross? Okay. It only crosses once at 3. Okay. Notice there's no negative 3. The real answer, it turns out, is just positive 3. So if I go back here, my answers that I got were x equals 3 and negative 3. It turns out negative 3 is an imposter. My only solution here is x equals 3. So the question is, why? And that's where the domain comes in. What you have to do is whenever you're solving a log problem, you have to check your solutions. Right? And so to check, you don't have to go all the way with it. Just imagine your answer. Your answers into the original equation. And all you're checking for are the insides of any logs negative? If they are, then you throw it out. So what I did here are to show that it's not an answer, but not having to graph it, because graphing it's not going to count on the exam. What you do is you plug them into the original equation. You have 2 log base 5 equals log base 5 of 9, and then the other one, 2 log base 5 of 9. So my 2 answers were 3 and negative 3. I'm not going to do any solving. I'm just going to look at it this way. So is that legal? Can I have log base 5 of 3? Yes. Then I go to the other one. Is that legal? Can I have log base 5 of negative 3? Remember that the domain of a log is 0 to infinity. So this log can't exist because it's not in the domain. So that's why we cross it out. So the inside of the log is negative, so I cross it out as a solution. It doesn't mean the answer is negative. It means that when you plug it in, after you do some math, if the inside is negative, then it doesn't work. Again, another point to that is if my equation was log base 5 of x squared equals 9, sorry, log base 5 of 9, then both answers would have worked. If this was my problem, I would have plugged in 3 squared, and that works. I would have plugged in negative 3 squared, and notice that negative 3 squared is positive. And so if this was my equation, my answer would be negative 3 and 3. It would be both of them. It all depends on your original equation. So this is my original equation, so I have two answers. But my original equation for the problem wasn't that. It was 2 times log base 5. And so when I plug negative 3 into the log, it doesn't work. Okay, so I know that's a little confusing, but going back to Desmos, notice that if it wasn't this, if it was log of x squared instead, notice that the domain, I now have both answers, negative 3 and 3. But because it wasn't like that, because it was just a 2 on the outside, that messes with the domain. And so I end up with just 3 as my answer. So this gets a little tricky because sometimes you'll get the right thing, but it'll say you're wrong because some of the answers weren't actual solutions. So on the exam, if you make that mistake, I'm not going to like count the entire problem wrong, but I'll probably take off 2 or 3 points. All right, so let's go to the next problem. I'm trying to shrink everything. All right, so this next one, I'm actually gonna, let's see. No, I guess I'll do both. So for this problem, I have log base 7 of x minus 1 equals log base 7 x plus 3, blah, 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 log base 7 x minus 2, log base 7 x plus 6. So if you want to earn yourself the Steaming Poo Award, all right, then do this. On multiple choice exams, there's always an answer where we show this as the solution, and there's always someone that picks it, and I cry on the inside. So this right here is extremely wrong. You can't drop the logs. Okay? The reason is there's not one log on each side. There's 2 logs on each side. In order for this to work, I have to rewrite the problem so that there's only 1 log on each side. Once I do that, then I can drop the logs. So please, please don't do that. I get sad. All right, but anyway. So in order to get this to where there's 1 log on each side, notice that I have log plus log. And the rule from Tuesday is, remember, it was log of m plus n equals, sorry, I just butchered that. Don't do what Gilbert did. So if you have 2 logs being added, you can bring them together with multiplication on the inside. So it's 1 log. So log base 7, And then on the inside, it's going to be x minus 1, x plus 3, equals log base 7. And I do the same thing over here because they're being added. So I get x minus 2, x plus 6, and there you go. So now I have one log on each side. So now the logs can go away. So I can drop my logs. And I'm left with a problem that's it's an algebra. FOIL each side. So x squared plus 3 minus 1 is plus 2x minus 3. X squared plus 6 minus 2 is plus 4x minus 12. X squareds go away. So I'm going to give myself some room. I have 2x minus 3 equals 4x minus 12. And we solve. So I subtract 2x from both sides. Negative 3 equals 2x minus 12. Add the 12 to the other side. That's 9. So x equals 9/2. Okay, so there you go. Now for my check. Is it an answer? Now when you're checking, again, you don't have to actually do the entire problem and see if like 1 equals 1 at the end. What they want you to do is, remember this is 4.5. 9/2 is equal to 4.5. So all you're going to do is you're going to go to the original problem. So to check, let me write that here. You plug into the original problem. And check the domain. But it has to be the original. I butchered the word original right there. All right. So my 4.5 answer, if I put a 4.5 right here, is 4.5 minus 1 positive? Yes, it is. Is 4.5 plus 3 positive? Yes, it is. Is, I'll just put check marks. Remember, we're checking to see if it's positive. So 4.5 minus 1 is positive. 4.5 plus 3 is positive. 4.5 minus 2 is positive. 4.5 plus 6 is positive. Since all of those are positive, then yes, this is a solution. If just one of them doesn't work, there's no solution. So you could have a problem with 99 logs in it, and if just one log doesn't work, it's not a solution. All right, so let's do this next one. Very similar, except instead of the product rule, it's going to be the quotient rule. So hopefully, from looking at the previous problem, the only difference is that they're minuses now. So I have log base pi x minus 5 over x, log base pi x minus 6 over x plus 4. And from there, the logs go away. So now you have a problem with no logs in it. We do our cross multiply. I know it's a bad word for me to say, but for the sake of time. So I have x plus 4, x minus 5 is equal to x minus 6. X squared minus 5 plus 4 is minus x minus 20. x squared minus 6x. Notice the x squareds cancel out just like they did last time. And I'm left with a little problem to solve. I have negative x. Let me write it over here. Don't want to run out of room. Whoop. Negative x minus 20 equals negative 6x. Well, let's see. I can add the 6x to the other side. So that gives me 5x minus 20 equals 0. I can add the 20 to the other side. I can divide by 4, divide by 5. And so I get x is equal to 4. But the question is it a solution? Well, let's mentally plug it in. If I put 4's here, notice that 2 of them check out. This 4 plus 4 is 8. 4, that's positive. But notice that 4 minus 5, this right here, doesn't check out. This right here doesn't check out. And so because 4 minus 5 is negative 1, 4 minus 6 is negative 2, this is not a solution. And so in this problem, since there's no other alternatives, we say that there's no solution. Okay, so you mentally plug the number into each log in the starting problem. And when you plug it in, the inside answer has to be positive. Sorry, yeah. So even though 4 is positive, that's not what we care about. We care about, once we plug it in, is what's left, positive or negative. So 4 minus 5 was negative. 4 minus 6 was negative, so that's why it didn't work. All right. Got some more problems, some word problems, and then we're done. I know this is a long section. So, the last type of problem I'm going to do is not everything is a log. And so what you're going to do here is you're going to condense to one log. And then you're going to convert. That's basically it. Okay, condense and convert. So if not everything's a log, like in this case, notice that this term here is not a log. So I can't use the method that I used up here. If everything's a log, then you get one log on each side and you can drop them. But that's not a log. So I'm going to condense. This is log base 5 of x plus 3 times x minus 1 and equals 1. And yeah, that's all you got to do. Now we convert. So when I convert, my base is 5. So this is going to be 5. The inside becomes the answer. And the answer goes on the inside. So my inside part becomes the answer. The answer goes on the inside. And for exponentials, the inside is the exponent. So I have 5 to the 1 is equal to x plus 3, x minus 1. And notice we end up with a quadratic. Minus x plus 3 is plus 2x minus 3. Subtract the 5. Minus 8. Again, with quadratics, we cannot solve by moving stuff around. We have to factor or use the quadratic formula. So, this one can be factored. This is 0 is equal to, let me again give myself more room. 0 is equal to, this is x plus 4, x minus 2. squared minus 2 equals 4. Yeah. And so we end up with two solutions. X is equal to negative 4, and x is equal to positive 2. Okay, now I got to check. So I go to the beginning, and I mentally kind of plug in a negative 4 here. Is negative 4 plus 3 positive or negative? That's negative. Okay, negative 4 minus 1 is negative. So because of that, this is not a solution. Now I try the 2. Two plus 3, 2 minus 1. Notice that that's positive, positive, everything's positive. And so 2 is my solution. So I only have one answer here. It's 2. Yay! So notice it's not too bad. It's kind of happy. All right, number 5. Same idea as before, except instead of multiplication, we're going to be doing division. So one log equals 1. And now the conversion. Now, if there's no base present, remember that the base is implied to be a 10. So this is going to be 10. And then we have our pieces. Exponent, answer, equal sign. Okay? So the answer, oh, I just shifted things around. So the answer, put the wrong one. Oh, God. Sorry. The answer becomes the exponent. The inside becomes the answer. So this becomes 10 to the 1 equals 2x over x minus 3. And now we have just a happy little algebra problem to solve. Multiply both sides by x minus 3. So now there's no more logs. We're just dealing with a problem like you would see in high school. So this is 10x minus 30 is equal to 2x. This is not a quadratic, so I can solve it by just moving things around. So I'm going to subtract 2x. I'm going to add 30. Divide by 8. Okay, so that's the same thing as divide by 2. So that's 15 over 4. Okay, so 4, 8, 12. That's 3.75. So if my answer is 3.75, if I plug that in, two times 3.75 is positive. 3.75 minus 3 is positive. So it all checks out. I keep it. So my solution, you can write it as 3.75, but I like the fraction form. Keep that as my solution. Fun times, right? Oh, man. All right, last one. Again, this isn't anything different than the other two. The only trick, quote, quote, trick that I did was you have to add the log to the other side first. Okay, so in order for this to work, I'm going to add the log to the other side. And we do exactly what we did in problem 4. So in problem 4, I have log base 2 of x times x minus 2 equals 3. And we convert. The base is 2. And so just like last time, the answer becomes the exponent. The inside becomes the answer. So this is a 3 x minus 2. 8 equals x squared minus 2x. Notice we have a quadratic. I subtract that. And again, that can be factored. That's x minus 4, x plus 2. And so if you solve each one, remember I skipped it last time, but you said each one equal to 0. So that's why it appears to be the opposite. So x equals 4, x equals negative 2. Let's see if any of them are fake. What you do is you go back to the original problem. And if I put a 4 here, that works. 4, so that's positive. 4 minus 2 is positive. So that checks out. So 4 is a solution. Negative 2, though, and you can see right off the bat, negative 2 doesn't work. Negative 2 minus 2, that doesn't work. So negative 2 is not a solution. Okay? But remember, just because it's negative doesn't mean it's not a solution. It's when you plug it in is where you see if it's a solution or not. Okay, anyway. So that's all the solving problems in this section. I know there was a lot. The only one that I felt like I was able to skip was 2 because it's exactly like 1. But all the others had something a little different, so that's why I did them all. Now the last 2 examples here are word problems. And they're not too bad. All they want you to do is just solve like we had been doing in the above questions. So this question starts with caffeine, blah, 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 da, 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 kidneys, blah, 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 blah. And then they give you the equation. So we're not learning how to create equations yet. They have to give them to you. Creating equations will be Tuesday's lecture. So there's my equation. And I know that C is equal to the amount of caffeine remaining whereas T is equal to hours. That's all I need to know. So how long will it take? That means we're going to be solving for T. For the amount of caffeine to drop below 60 milligrams. And that's my value for C, round to 1 decimal place. So they're giving me C, and they want me to solve for T. That's it. So I have my equation. I'm looking at it over here. So C is 60 is equal to 80, parentheses 2, raised to the negative T over 6. All right. So my exponential term is this guy. The exponent just affects the 2. It does not affect the 80. Before I do any logging or anything like that, I have to get the exponential term by itself. So I divide by 80. 2, 4, 6, 8, that's 3/4. 2 to the negative T over 6. And how you want to solve it is up to you. You can log both sides, or you can convert. I'm going to do the log both sides route. That's the route that they tend to take for exponentials. Whereas for logs, they tend to convert. So if I log both sides, I end up with, here's the 3/4, 2 to the negative T over 6. That allows this number to come to the front. So log of 3/4 equals negative T over 6 times log of 2. And now I just got to solve for T. So let's multiply by 6. Equals, I'm going to rewriting it so that you can see when I divide, I'm going to divide by negative log 2. Okay, so I took the 6 to the other side. And now I'm going to divide by negative log of 2, which I kind of ran out of room. Bad Gilbert. Can he do it? Oh, nope. There we go. The C is going to be affected. It's an art. Okay. So I can divide both sides by negative log 2. I drop my remote on the floor. In case you're wondering, they're showing South Park in the background, and that's kind of what I watch when I'm just not doing anything. That or Frasier. So my final answer is t equals bad manners to have the negative on the bottom, so I'm going to put the negative on top. Negative 6 log of 3/4 over log of 2. But you can't tell someone, like, how long does it take for there to be this much caffeine? You can't say it takes negative 6 log 3/4 over log 2 minutes, or 2 hours. Instead, what you have to do is type it in your calculator and see what you get. Notice it says round to 1 decimal place. You don't need to watch Frasier. I know it was like a 90s. It ended in 2003, 2004, I think. But it's a really good show. Like, if you want to watch like the best that sitcom has to offer, watch Frasier. Like, seriously, like all 90s sitcoms had laugh tracks because that's just what people did. But you're watching it and you don't even notice the laugh track because it's just so good. The writing is amazing. Negative 6 log 3/4 over log of 2. And so I get 2.5. So round to 1 decimal place. So about 2.5 hours. There you go. So all they wanted to do, fancy word problem, but all it was set the equation equal to 60 and solve. Okay. Laura has trouble sleeping if she has more than 30 milligrams of caffeine in her bloodstream. So this is exactly the same thing, except now instead of 60, we're going to set it equal to 30. You know what? This is exactly the same as the previous one. So do part B on your own. All you're doing is you're setting it equal to 30. So, and basically do exactly what we did in part A and see what you get. I'll post the video to Canvas. All right. So now this last problem. A new teaching method to teach vocabulary to 6th graders, blah, 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 has been learned. After lesson completed, students were tested at 1 month interval. The average score for the class can be modeled by. So they give us the equation, where T is the time in months. So T is the time in months after completing the assignment, and S is the average score. So they're telling us if the average score is 65, they're giving us the answer. They're basically saying since S is right here, they're telling us to set the equation equal to 65. And solve. Now the answer we get is going to be in months. Okay, so basically they're saying that if you teach a topic and you test over that same topic but every month, then the scores should slowly go down as you keep testing it. Because the more and more time that's passed since you've taught it, you tend to lose information. So if the score was a 65, how long ago was the lesson taught? Is basically what they're saying. So 65 equals 94 minus 18, natural log of t plus 1. Now, here's my log term. That has to be alone before I can do anything. So I got to move stuff around first. Don't want to do math in my head. 65 minus 94 is negative 29 equals negative 18 ln of t plus 1. I can divide by negative 18. And I'm just going to leave it like that. 29 over 18 can't really be. So I have 29 over 18 equals ln of t plus 1. Well, just like we did on the previous page, I solved this by converting. Remember, when you have an exponential, when you have ln, the base that's implied is e. So if I convert this, it's going to be e. The answer goes on the inside. The inside becomes the answer. So e to the 29 over 18 equals t plus 1. And then all you got to do now is subtract 1. So t equals e to the 29 over 18 minus 1. And round to the nearest month. So they want me to round to the nearest whole number. So e second ln to the 29 over 18 minus 1. So notice that's almost an exact 4. So if I taught a topic, let's say you taught a topic in January, and if I tested you over that topic in April, then it's been a long time since you learned it, so the grade would be a 65. The more time that goes on, the more time goes by. Anyway, I know this lecture was a little long, a lot of problems to do, but yeah, this is the toughest section in this exam, solving equations for x. I think that probably 30 points of this test comes from this section. So you have to know how to solve each type of equation. I notice there are different types. So when you're solving these, you have to break them into stereotypes. Does it fit the first stereotype? You solve it that way. Does it fit this stereotype? You solve it that way. Each one has a different solving type. Does it fit this stereotype? You solve it that way. There's another stereotype. There's another stereotype. So in this section, there was 5 different stereotypes for problems, and each one had its own way to solve. So please email me if you have any questions. This gets pretty tough. Anyway, have a good one, guys. Be safe.